This project should not have taken this long. When I got started on this game back in August of last year, my thinking was that I want to replicate a simple game and see what it would be like to make a game to completion. I had not expected it to take more than a month, but here we are in the Feb of 2023 and only now is the game looking kind of like a finished project. Why did it take so long? Well, it mostly comes down to my own laziness. I did not consistently work hard on the game. In fact, for almost 4 months, I did not work on it at all. A few things happened in life. There was college, I got an internship, so I had to give time there. So I could at least make some excuses, but that doesn't change the result. Also, this project is much older than this channel, and when I started it, I had no idea that I would be making a video about it. So I don't have footage for its early stages of development. So you'll have to bear with me as I revert back to old commits and see if I can get anything. That being said, let's get into the actual devlog. Let's start with the setup first. I knew that making this game in an engine would be very easy. There really isn't much to it. So I set out to build it without using an engine. It will allow me to learn how certain things that an engine handles for us are made. I decided to use C++ and SFML as I was already a bit familiar with it, having used it for a project in my second year of college. It provides a simple API for creating a window, drawing sprites to the screen, playing audio, detecting input, etc. So I didn't need to develop these things from scratch. But other than that, it does very little in the way of actual game development. So all of those things I had to make by myself. So let's start by creating a window and drawing sprites to the screen. I drew this simple sprite for a spaceship and created a sprite class, which is basically a wrapper around the sprite class provided by SFML that takes care of some of the repeated code. I also created a simple starry background, and this is what the scene looks like now. Cool. We need movement. Now we could just translate the spaceship through the scene if we press WASD keys, but that wouldn't feel right. So I decided to implement a simple physics system. This really wasn't that hard as we are in space and don't need to worry about things like drag or gravity. I created a class called rigid body. Every rigid body should have a mass, and then we have a method for adding force to this body. When we apply force to this body, we can calculate the acceleration produced by this force by this simple formula. Then we can add this acceleration to the current velocity of the body. Every frame we check the current velocity of the body and displace the body in the appropriate direction. We can also have a max velocity, so we can cap the movement speed of objects. Here's what it looks like in the game. Nice. But we have a problem, and that is going off the damn map and never returning. We can't have the player exploring the uncharted depths of this mysterious and dangerous world, so we need to add some warping to the scene. So if the player disappears at one edge of the scene, they just appear at the other edge, keeping them in the playing area. Next up, the player should be able to aim their main cannon. To do this, the spaceship needs to be able to rotate. Instead of adding two buttons for rotating the spaceship left and right, I decided to simply have the spaceship face the direction of the mouse. This provides more precise aiming and allows for quicker turns. We can do this by first calculating a vector pointing from the spaceship to the position of the mouse relative to the window. Then we can use the inverse trigonometric functions to calculate the angle between the x-axis and the vector. We set the rotation of the spaceship to this angle, and there we have it. Something doesn't feel right. Turns out that in SFML, the origin of a sprite is set to the top left corner, and so the spaceship is being rotated about this vertex rather than from the center. In the sprite class, let's change the origin to the center of the sprite by adding an offset of half the width and height. That seems better. Here, I also noticed an issue with how the velocity of the rigid body was being clamped. Right now, if a rigid body reaches max velocity, we just stop adding any more force to it. And this is obviously not the way to do it, because it means if we apply an opposite force to slow down an object, we can't do it and it will continue moving at max velocity. What we can do instead is keep adding the force regardless of the current velocity, and if the current velocity exceeds the max velocity, we can simply scale it down to max. That way the body can be kept at or under max velocity while still accepting input. Now let's start firing that main cannon. I created a simple sprite for bullets and a bullet class that inherits from the sprite class. In its constructor, we set where the bullet should spawn into the world and what direction it should be fired in. I have fixed the mass, the force of fire and max velocity of bullets for now to make things a bit easier. Then in the spaceship class, we create 2 counters to keep track of firing the gun. We have current charge and recharge speed. Every frame we fill up the current charge meter using the recharge speed, and when it reaches full charge, if the player presses down the mouse button, we light the fuse and fire the round. As mentioned earlier, we need to provide the bullet a position to spawn into the world, which would be the tip of the spaceship, but it changes as the spaceship rotates and moves, so it has to be calculated every time we fire. Also, we can't let these bad boys roam around the map without having a reference to their memory. So I used an unordered set for this, which is like a hash set. It allows us to quickly add and delete bullets from the container without having to search for them. Then I added some code that deletes the bullets once they leave the screen, so you can't hit asteroids before they arrive in the playing area. Then it was time to create the actual asteroids. I thought of drawing up a few sprites for them, but then had a better idea. We could procedurally generate the asteroids in the game itself. I thought of a few ways we could do this, and here's what I settled on. Let's take a circle to make things easier to visualize. Now suppose we want to have an asteroid with 9 vertices. We can place these 9 points on this circle at regular intervals. Then we can change the distance at which these points are located by some random factor. Then we can just join these points with a line to create a decent looking asteroid. I felt like such a genius after figuring this out. It's moments like these that make me fall in love with game development and computer science in general. So I added some code to generate asteroids of random sizes, and I added the rigid body class to them and spawned them at a random point outside the screen. Then we select a random point inside the screen and push the asteroids toward that point using the add force method in our rigid body class. I also added a point in triangle collision test so we can destroy the asteroids with the bullets we fire. So we have asteroids in our game. I guess we can call it a day.
Oh shit, Here we go again.
For some reason that I do not remember, I didn't work on the game for the next 2 months. And even when I came back, it was like a few commits once a month. It was only when I created this channel did I feel responsible enough to go back and complete the game. So I sat back down, reinvigorated and determined to finish the game before I gave it up again. I made a few changes to how the code was structured and spent some time adding comments to the code. I also categorized the asteroids in 3 sizes, that is small, medium and large. And instead of having to set the radius for each asteroid that we spawn, I just set the small asteroids to have a radius between 25 to 50, 50 to 75 for medium and 75 to 100 for large. So now we only need to tell the game to spawn an asteroid of a given size, and the rest of the calculations is all taken care by the asteroid class. This change also allows us to implement one more feature. If a large asteroid is destroyed, we can split it and spawn 2 smaller asteroids in its place, just like it is done in the original game. We can take the velocity of the big asteroid, change the angle for it a little bit and launch the children asteroids in that direction. But there was a problem. Until this point, all asteroids were being launched with a constant force. That meant that asteroids with lower mass moved faster. That wasn't an issue if they were coming from outside the screen. But if a larger asteroid splits up in front of us and the smaller asteroids start suddenly going at twice the speed of the parent, it looks weird. Also, it breaks the laws of physics, but we are not too concerned about that. So again, I changed how the asteroid spawn and push works, and now we can fool the player into thinking that it's the same asteroid just split up and not a completely new one that materialized out of thin air. Or thin vacuum, as there is no air. One day I was just browsing through itch.io and I came across this program called Infinite Backgrounds. It procedurally generates space backgrounds in a pixel art style. I tried it and liked the output very much, so I downloaded it and made a lot of them and copied them to the project. Then I replaced my boring old background with these. Every time the game starts, it loads one of these randomly and sets it as the background. Then came time for the thing that I dreaded the most: collision detection. I knew since I started the game that simple AABB or bounding box collision detection won't work, and I won't be satisfied with it. I searched about for some time and found the SAT algorithm for polygon collision detection, and it felt like the perfect fit for the game as the asteroids were polygons and so was the spaceship. I made a full video about the theory and implementation of the SAT algorithm, so you can check that out for more details. Implementing the algorithm in the game was not that difficult after figuring out how it works. There was a weird bug being caused when I set the value of projection min to FLT max, that is the max value of a float. I wasted a lot of time as I kept thinking that the implementation I had done was at fault. A lot of printf statements later I found the issue, and fixing it was as simple as changing the value from FLT max to some other arbitrarily high value. I imagine that if I had known how to use the Visual Studio debugger, I would have found this issue much sooner. So I should take some time to learn it. Anyways, so on I went, adding some comments and refactoring the messy collision detection code, and set the game to exit if we collide with an asteroid. At this point I felt that the main gameplay loop was mostly ready, so I decided to add a start menu and a game over scene. I could have gone and created a scene management class for this, but because we only have a few of them, I figured that I'll just use a function based switch case. Here's how it works. We have our application instance that currently runs the gameplay loop. We can move it into a function called gameplay scene. Similarly, we can have different functions for start menu scene and game over scene. The application has a current scene value, and whenever it starts, it switches to that value. After we want to switch from one scene to other, we just return the index of the scene that we want to switch to from the function. So control goes back to the switch case and the application starts running a different scene. But then you may ask, how will we exit the game? Well, we can just switch to an unidentified scene index, say -1, and since such a scene does not exist in the game, it will exit. I used this system to create the two scenes I needed. I experimented with having sprite based buttons, but my art is horrible, so I switched over to having simple text based buttons. They look better and more consistent. After UI, it was time to add some sound. I hit up the internet searching the vast intergalactic network for some sweet space shooter sounds and background music. I found some amazing tracks, and adding them to the game was a piece of cake thanks to SFML's fantastic API for sound. There was one catch though. SFML doesn't support .mp3 files due to licensing issues, so I had to convert them to .wav. I added sound effects for shooting, asteroid destruction, and some groovy background music. Now every time I play the game, I feel like I'm really in space. Well, not really, but it is close enough for me. It would have been better if it wasn't for the ear rape it was doing me. I had to find a way to reduce the volume. At first, I just set the volume to 20% and forgot about it. But my brain kept reminding me that a more permanent solution has to be found. And so, I decided to make a settings menu. I added button controls for master, SFX and music volume and multiplied the max volume with these properties. Then I saved this onto a JSON file so we can load these values when we start the game to prevent any further eardrum abuse. Obviously, no C++ game could be made without having a few memory leaks, and so I set about looking for them. And sure enough, I found a few. So I sealed them up real quick, refactored the code, gave a final sigh, and clicked play. Finally, with a finished game under my belt, I have joined the ranks of the elite few of the gaming industry. I know I shall be remembered for a long time to come. I know I just said that the game was complete, but I want to add a few more things to it. Who wants to play the game in a tiny window with their desktop background constantly distracting them? I want to convert it to at least full screen 1080p, or even better have a resolution selector in the settings menu. I want to add a few optimizations to some parts of the code and see how I can push the FPS. I also want to balance the game, as right now it feels like you are entirely dependent on luck. Asteroids come swooping out of the void and wipe you out before you can turn to see them, like they have some personal vendetta against you. I also want to add some more mechanics to the game. Right now the player has little to no incentive to move. If you leave the center of the screen, the spiky bastards can strike you down even faster. It is just safe to remain in the center of the screen and play it like a tower defense game, which is not what I want. Maybe if the asteroids give power-ups after getting destroyed, the player would want to move about to collect them. There are a few other less important things I want to experiment with, but I think we should stop here for now. The game is somewhat playable and I think I should rejoice in the feeling that comes along with it. At least for now.